On the soccer field, we can make all triangles that we're concerned about into right triangles. So the Pythagorean theorem plays an important piece on the soccer field. We want to know either the distance, so that's like the length of a side of a triangle when we're on the soccer field, for the amount of force that we're putting on the ball, okay? The Pythagorean theorem, if a triangle ABC is a right triangle, then a squared plus b squared equals c squared. So if I have a right triangle, this side is labeled A, this side is labeled B, and this side is labeled C. Now you can use any letter that you want to label these, but this is commonly used when we're talking about a right triangle, because then we don't have to convert and think, well, what does the M stand for? Well, we just commonly use A, B, and C. C is always the hypotenuse. It is always the longest side of a right triangle, so it is opposite the 90 degrees. Because if you have a right triangle, and this is 90 degrees, and a triangle, the sum of the interior angles can only add up to 180 degrees, between these two angles, it has to add up to 90 degrees also, because 90 and 90 is 180. So these two angles separately have to be acute angles. So this is a right triangle. When you have a right triangle, you have one right angle and you have two acute angles. The longest side is always opposite the biggest angle. So the side opposite the 90-degree angle is the longest side in a right triangle, and it is specifically called a hypotenuse. In this triangle, A, B, and C are the side lengths of the triangle. A and B are called the legs. So the sides opposite the acute angles in a right triangle are called the legs. C is the hypotenuse, which is the longest side of a right triangle. So the Pythagorean theorem, if you have triangle ABC is a right triangle, then one of the legs squared plus the other leg squared equals the hypotenuse squared. That's what A squared plus B squared equals C squared is saying. Now these legs are interchangeable. It doesn't matter whether you use B squared plus A squared or A squared plus B squared. Those are interchangeable. The C is not. It's always equal to C squared. The converse of Pythagorean theorem. If you remember from one of your quarters in geometry, they probably talked to you about converse statements. Converse statement is if I have if and then, it switches it around. What's after the then, the conclusion, comes into the hypothesis, which is after the if. So it just flips it around. So the converse of the Pythagorean theorem says that if A squared plus B squared equals C squared, then I have a right triangle. So this is only true for right triangles. It determines if it's a right triangle, and if you have a right triangle, you can use it to find the sides. If a triangle has side lengths 6, 8, and 10, is it a right triangle? Why or why not? So here's my right triangle, and I have A squared plus B squared equals C squared. If it satisfies that, then it's a right triangle. So I'm taking my shorter two lengths, 6 and 8, those are my legs, 6 squared plus 8 squared equals my longest side, which is the hypotenuse, 10 squared. So 6 squared is 6 times 6, which is 36. 8 squared is 8 times 8, which is 64. And 10 squared is 10 times 10, which is 100. Okay, these three little dots, I use them a lot when I teach. They mean therefore. They mean the word therefore. So, in conclusion, okay? I use the three dots a lot when I teach because it's a faster way of writing therefore, and we use a lot of symbols in math to stand for some words. So, it's a good thing to know. The three dots mean therefore. Therefore, triangle ABC with side lengths 6, 8, and 10 is a right triangle because this works. 36 plus 64 is 100. So why? Because the converse of the Pythagorean theorem holds true. Okay. If the legs of a right triangle are 4 units and 9 units, what is the length of the hypotenuse? Since it is a right triangle, a squared plus b squared has to equal c squared, and a and b are my legs, so I plug the 4 into one of them, a, and I have 4 squared plus 9 squared. The 9 goes into the b. It can be opposite. So I have 16 plus 81 equals c squared. 16 plus 81 is 97. 97 equals c squared. I'm not looking for c squared, I'm looking for c. C is the length of the hypotenuse. So c has to be the square root of 97. So on a calculator, I plugged in square root 97 and I got 9 8/10. So the length of the hypotenuse is 9 8/10 units. And I don't need to put in the unit of measurement while I'm doing the math, but in the final answer, you should always have the unit of measurement. If one leg of a triangle is 5 centimeters and the hypotenuse is 22 centimeters, what is the length of the other leg in the triangle? Well, if the triangle has a hypotenuse, that it has to be a right triangle because hypotenuses only exist in right triangles. So therefore, one leg is 5 centimeters, so I have 5 squared. The hypotenuse is 22 centimeters, so I put that in for the c. So I'm looking for b squared. So 5 squared is 25 plus b squared equals 22 squared is 484. So I want the b squared alone because I want to solve for b. So I subtracted 25 from both sides and I get b squared equals 484 minus 25, which is 459. That means that the square root of b is square root of 459, which is, the square root of b squared is the square root of 459. So b is the square root of b squared. So b equals the square root of 459, which is b equals about 21 4/10. I don't have the about sign. I forgot it. I'm sorry. The other leg of the right triangle is 21 4/10 centimeters. So in summary, the Pythagorean theorem says that if a triangle ABC is a right triangle, RT is short for right, then a squared plus b squared equals c squared. So a and b are the legs and c is the hypotenuse. The hypotenuse is always across from the right angle, and it is always alone in the equation.